practical applications of science in our lives. Chemistry.
Chemistry is responsible for numerous reactions and interprets the relationship between substances. Our home is setting for countless chemical reactions by simply diluting solutes such as powdered coffee, powdered juice, dishwashing liquid, and many more to water to lessen the concentration. We are now applying dilution.
Dilution.
I'm Shannon Maeve Argalian, and I'm going to explain the experiment of dilutions of solutions. So the first experiment that we're going to do is diluting or juice to water to obtain lesser concentration of solutes, or instance the juice is too sweet, thus we add water.
Limiting an excess reactant.
Next is limiting an excess reactants. I'm going to explain to you limiting an excess reactants in a simple way using sandwich. We use 12 slices of bread and 5 slices of cheese to make cheese sandwich. For this, limiting reactant is cheese and excess reactant is the bread. How? The limiting reactant is the one consumed first and that limits the total amount of the product. To determine it, we should calculate the number of moles of each reactant in a product and compare the ratio in a balanced chemical equation.
Physics, electromagnetism, and alternating current.
Physics plays a major role in our everyday life. Moreover, electrical energy is one of the salient topics and applications of physics in our lives. Specifically, electrical energy powers our appliances and creates forces that allow a certain device or machine to work.
Hello everyone, for today's experiment, we are going to create a DIY electromagnet. Initially, what is electromagnet? Electromagnet is generated by an electric current which is conducive in creating energy that powers appliances and numerous devices.
Materials, we have D-size battery. We are going to use nails or anything that is made with iron, as well as paper clips, sandpaper, this, and electrical tape, as well as copper wire and pliers.
So that is all for physics applied and explained in day-to-day life. I hope you learned something. Thank you. Wonder how electronics work in our respective homes? Today, we are going to discuss alternating currents and how it works. Alternating currents power our appliances every day, such as our refrigerator, electric fan, light bulbs, and many more. Likewise, any appliances that are connected to a power socket and obtain energy from the main power supply receive alternating currents. The process of acquiring energy from alternating current starts from the power plant. Then the energy is carried via transformer where it controls voltage levels, and next is dissemination of energy via distribution lines to every home which powers daily appliances.
Biology.
After we have seen and learned about the two topics, general physics and general chemistry, we will move on to general biology, where we will discuss the feedback mechanism. First, what is feedback mechanism? A feedback mechanism is a physiological regulatory system that either returns the body to our normal internal state or homeostasis, or less commonly brings an internal system further away from homeostasis. Two mechanisms exist, negative and positive. These act via nerve pathways or chemicals such as hormones to cause a stimulatory or inhibitory effect. Feedback mechanisms are also found in ecosystems.
What is homeostasis? It is any self-regulating process by which biological systems tend to maintain stability while adjusting to conditions that are optimal for survival. If homeostasis is successful, life continues. If unsuccessful, disaster or death ensues. The stability attained is actually a dynamic equilibrium in which continuous change occurs, yet relatively uniform conditions prevail. Importance of feedback mechanism is that feedback loops are important because they allow living organisms to maintain homeostasis. Homeostasis is the mechanisms that enables us to keep our internal environment relatively constant, not too hot or too cold, not too hungry or tired.
Negative feedback. The regulation of body temperature by endotherms is a good example of a negative feedback mechanism in the human body. The brain sends signals to the numerous organs, including the skin, to release heat in the form of perspiration when the body temperature increases above average. The temperature drops to the point where the negative feedback mechanism's pathway are shut down as a result of these physiological events. A similar system is activated when the body temperature rises above its normal level to maintain homeostasis. Positive feedback. Menstrual cycle. Before a woman ovulates, the hormone estrogen begins to release in her ovary. The estrogen hormone travels to the brain and causes two other hormones to be released. The pituitary gland is prompted to release luteinizing hormone once the brain is engaged to release gonadotropin hormone. Luteinizing hormone boosts estrogen production. Ovulation is triggered by an increase in these hormones, as well as follicle-stimulating hormones. In response to the stimulation, the control unit produces these hormones. The ovaries subsequently release estrogen as a result of these hormones, and the cycle continues until the levels of these hormones are high enough to trigger the release of follicle-stimulating hormone.
And that's it, ladies and gentlemen. We hope that we gave you the importance of science in real-life situations through specific examples in our own unique way. We'll see you in our next video. Bye!